welcome once again to our industrial electronics session. I'm C. Tobejane, and in today's session, we'll be looking at bridge network, which is module 2 of our TVET First textbook, Industrial Electronics N6 by Macmillan and Trop and Publishers. Today's example is extracted from example 2.2 from the same book. Now, the example reads as follows. A detector bridge consists of three standard resistors, each having a resistance of 2 kilo ohms and a resistance thermometer with a nominal resistance of 2 kilo ohms at 30 degrees Celsius. The temperature coefficient of the resistance thermometer is 0.001 ohm per degree Celsius. The bridge supplies a voltage of 4 volts. The question wants us to determine the detector voltage when the thermometer temperature is at 95 degrees Celsius. Now, that is number A. How do we go about doing this now? The first thing that we need to do is to calculate, the first thing that we would need to do is to calculate the change in resistance. The change in resistance would be calculated by the change in resistance in temperature, the nominal resistance, RT. Let us call this an Rn, which is the nominal thermometer resistance, multiplied by the temperature coefficient. I will use a C to indicate a temperature coefficient. Now, the change in temperature here, because they want us to calculate when the thermometer temperature is 95 degrees Celsius. So we're going to say 95 degrees Celsius minus 30, which is the initial temperature where the nominal resistance is at, multiplied by the value of the nominal resistance, which is 2000, multiplied by the temperature coefficient, which is 0.001, just like that. And then we'll punch that directly to our calculator. Remember, folks, each time when you're about to do new calculations, I always advise this: reset your calculator so that it is at its default state. This will eradicate any issues that may occur during your calculations. So our change in temperature in this case is given as 130 ohms. 130 ohms, just like that. So now we need to calculate the amount of thermometer resistance we're looking at the change in temperature as well as it being affected by the nominal resistance. So RTH in this case at 95 degrees Celsius, at 95 degrees Celsius would be equal to the change in resistance plus the nominal resistance. Let me write Rn for as a subscript for that. So this should be 130 plus the 2000 ohm, indicating the nominal resistance. This should give us 2130 ohms. But remember, the question wants us to calculate the detector voltage. Detector voltage is known as VD. The equation to calculate our detector voltage, VD, is given by the supply voltage, Vs, into R1 divided by R1 plus R2 minus R3 divided by R3 plus your thermometer resistance. I want to believe that you've already seen the circuit diagram or the network diagram of a bridge network. That should be in the previous page of this example in your textbook. So there you would be able to see these resistances that are available there. You would see where your detector voltage would occur in that case, as well as where your supply voltage is connected in that circuit. And at the same time, you'd also see your thermometer resistance where it occurs. In this case, we are given a bridge that has three standard resistors. Those three standard resistors are R1, R2, and R3. R3. And at the same time, we're then given a resistance thermometer with a nominal resistance of 2 kilo ohms. So with that is that. But in this case, we needed then to calculate the thermometer resistance, not a nominal resistance, which is why we calculated it this way. So here what we'll do is we'll then make our substitution here. We're having 2000 ohms divided by 2000 plus 2000, since all resistors in this case are the same. The reason again why we would have all our resistors being equal is so that the bridge would be balanced, right? When all the standard resistors in the bridge as well as the thermometer resistance are equal, the bridge is set to be balanced, and the output, which is in this case the detector voltage VD, will be zero. Do you understand that? So now, because our thermometer resistance, as we've calculated here, is no longer equal to all these resistors that are there in the circuit, it means that the bridge will not be balanced. So we need to calculate, in this case, the detector voltage. I hope that makes perfect sense though. So this is 2130, just like that. Now we punch in our calculator. For that, this would be 4 into 2000 divided by 4000. Let me say 4000 minus 2000 divided by 4130, just like that. This should then be able to give us 0.063 volts. Where am I getting the 4000 here? It is 2000 plus 2000. The 4130 here is 2000 plus 2130. It's math. So this would be 0.063 volts. This is our, or rather the value of the detector voltage. This equation is available even on your formula sheet. I always advise my students that there is a difference between practicing and studying. When you are in attendance of classes, that is before an assessment task or an examination, you are still in the period of attending classes. Avoid using previous question papers to study, because the moment you bring in a previous question paper, you are no longer studying, but you are practicing. It means that you need to use previous question paper to practice for an assessment or for a final examination, but you cannot attempt to answer previous question papers before you study. I always say, in your study room, ensure that you have a formula sheet pasted on your wall. The formula sheet will be used as a reference from your book when you are studying. It means that each time you encounter an equation in your textbook and in an example, try to highlight that equation in the formula sheet. This would assist you in identifying equations or formulas that are provided to you during the examination and those that are not provided to you during the examination, which obviously would also give you a better understanding of how to use these formulas. In that way, when you now approach the exam, it will be easier, to just quickly go and pick a formula because you're already used to these formulas. You can only do that during study periods, not during practice periods. So this equation VD is available in your formula sheet. Please do check that out. And the last question here, they're saying a suitable feedback resistor for an operational amplifier if the above detector voltage is used in a 3 volt to 7 volt amplification network. The metering resistance in this case would be 2 kilo ohms, and the output voltage must be 7 volts at 95 degrees Celsius. It sounds like a very tricky question, but it's just as simple as it, you may calculate as, and as you see in your textbook. So here we need to calculate a suitable feedback resistor, that is RF, for this operational amplifier that uses the detector voltage above. And the detector voltage must be used at the range of 3 volts to 7 volts. Obviously, would use the maximum voltage at that amplification network. And here we're given that the metering resistance in this case, which is RM, RM is a metering resistance. We could also use RM as an input resistance as Rin, and the output must be 7 volts at 95 degrees Celsius. Equation to use here would be given by V out is equal to V in into 1 plus RF Rin or RM. We need to make RF subject of the formula. That is the feedback resistance that we're looking for. So when you make RF subject of the formula, the equation you'll end up with would be RF is equal to Rin into V out over V in minus 1, right? Let us substitute that Rin is given as 2000. V out, they said we must use 7 volt. V in this case is the detector voltage that they said we must use. So that will be 0.063 minus 1. See, we are using it in that detector voltage phase. 2000 into 7 divided by 0.063 minus 1. Just like that. Let us write it in kilo ohms. So that will be 220.222 kilo ohms. So it's 220.222 kilo ohms. That is how you attempt this question number B. Now, an examiner would very much like to ask you this type of questions, and they would appear the most in the exam. So you need to practice and you need to study. So it's study first, practice later. You only practice when you're about to write assessments. You study when you are still in class. That's it for me today, folks. Let us hope that you have enjoyed today's session. Let us meet again for another exciting session of industrial electronics.